Good afternoon. So firstly, thank you very much for taking time out of what is obviously a very busy schedule to come to this session to hear me talk about BitLocker drive encryption. I'd like to say a thank you to all those of you who came just a little bit early and patiently waited for our 3:45 kickoff. Thanks for that. It's actually kind of important we go on time because those people at the back there are recording me for time immemorial. So if the demo gods are unkind to me, apparently everyone gets to see it on the web. Anyway, so I'm here to talk about BitLocker drive encryption. I'm going to cover a number of subjects. I'm going to give a quick review, a recap of BitLocker. I'm going to work on the assumption that most of this audience has at least heard of the technology, so I'm not going to spend too much time on the recap, but I think it's important to quickly go over what BitLocker is at a high level, why it exists. I'm then going to dive into some new technologies that we've added in BitLocker in Vista SP1. Perhaps most importantly, kind of the giveaway up there, we now have multi-volume support in SP1. I'm going to talk about what that means, the value it adds, how you can leverage it, show you how it kind of works under the covers, talk about some key management and key release mechanisms, some security decisions that you may need to make, and all that good stuff around multi-volume support. I'm then going to go back into a components deep dive. I'm going to talk about the TPM, which stands for Trusted Platform Module. I'm going to details about the parameters you have within Vista to be able to set exactly what and what is not measured by the TPM in our implementation of the static root of trust. I'm going to talk about keys, key management, key layout, our keying scheme for BitLocker, and the fact that we allow you to re-roll keys thanks to an abstraction key, and our models for that, disk layout, encryption model, recovery. And I'm also going to talk about something really exciting. There's a few things in here that you guys are the first to see, as far as I'm aware, at least first official to see. The first of which is the multi-volume support, but also some really interesting real-world examples of how we've blended BitLocker technology with other Vista technologies. I'm going to roll through some pseudocode flowchart type examples and actually give you some demonstrations of that. That's an absolute first for you guys. So what is BitLocker drive encryption? Well, as the name suggests, it encrypts drives. It's a pretty kind of well-named product, really. Why is full volume encryption, the concept of encrypting an entire volume or a drive, important? Well, it helps address certain threats. It used to be called the lost laptop scenario because that was the main threat. The real threat that BitLocker is addressing is the protection of data at rest. Data at rest counts as information that exists on the hard drive that's not being protected by the operating system on that hard drive. So the files and folders on that hard drive are not being protected by the OS because perhaps you've booted another operating system on a CD or a DVD, or perhaps you've taken the hard drive out of the laptop or desktop or server and slaved it to another machine, and you're using forensic tools to investigate the data that's on that machine, which you can actually quite easily do if the host OS is not protecting the file system. And even though we all may think, well, that's okay because I have EFS or perhaps a competing file protection product, or I have RMS or some other rights management type product, then there's still places on the disk the data can leak. In fact, it's kind of amazing exactly how snippets of information can spread themselves willy-nilly all over a hard drive. Temporary files, swap files, so-called deleted files that aren't actually deleted. The registry itself. There's a lot of very interesting information to be found on a hard drive, especially if the operating system isn't there to protect it. And the only real way that you can make reasonable guarantees about protecting all the contents on that drive is to encrypt the entire contents of the drive at the drive level. In other words, at the block or cluster level. And that's what BitLocker drive encryption does. It solves some interesting problems. I'll come back to some of those problems in a minute, but it solves some interesting, so where do you put the key problems? If you've just encrypted the hard drive and you've encrypted everything on it, you've encrypted the operating system. The problem you've then got is, well, where do we put the key? Because if you've encrypted the OS, how does the OS boot? So the Trusted Platform Module allows us to solve that in an interesting way. I'll come back to that in detail. And we've made some enhancements to the authentication mechanisms that are available in BitLocker for SP1 to allow a new form of multi-factor pre-boot authentication. But perhaps most importantly, we've enhanced BitLocker in Windows Vista SP1 to provide multi-volume and multi-drive support. I'm sure as many of you are aware, in the original release of Windows Vista, BitLocker allowed or only supported the encryption of C:\WAC, which basically is your OS drive. Right? That was the single volume that it allowed you to encrypt. Or we supported you encrypting, let me put it that way. Well, we fixed that in SP1. It wasn't really a bug per se, it was a release decision, frankly. But a lot of customers said, look, we need multi-volume support, multi-drive support, especially for desktop and branch office server scenarios. So we're providing multi-volume support in SP1. Let me give the definition of what a data volume or drive is. It's any, as it says, any non-active volume that hasn't got the current operating system on it. But the keywords there really should be that are attached to the machine. So if you've got, let's say, a laptop drive with 2 partitions in, which is probably one of the most common configurations, a C: for your OS and programs, perhaps a D: for your data and maybe personal applications, SP1 will support that. If you've got 2 drives with maybe a C and a D on drive 1 and an E that spans, fully supported. Multiple drives in the machine, also supported. What is not supported is roaming volumes, the concept of a volume that you may plug in via a USB stick. That is not officially supported. We've got the concept here of auto-unlock key. I'm going to come back to that in a little more detail, but in simple terms, a data volume has a number of methods in which it can unlock, i.e. gain access, or from a technical term, actually allow the operating system to mount it. I'm going to go into some detail with that just about now. Excellent. So here's my laptop. As you can see, it has a number of drives on it, 4 of them actually. You can see it's got a C:, which is marked as an operating system drive, and that's actually BitLocker protected. We've got an E: and an F:. Both of those are actually BitLocker protected. If I go into E:, you can see it's actually got a bunch of documents in it. They're fully protected. I've actually got an F: here, and I'm going to come back to that in a second. That's also BitLocker protected, but I don't seem to have access to it. Well, there's some good reasons for that, but let me also show you some proof that those drives are actually encrypted by using this wonderful little tool that some of you may have already seen. It's really difficult to demonstrate encryption on a hard disk. You can either kind of take my word for it, or frankly not. All right? Because the point of seamless hard drive encryption is, well, it's seamless. This demonstration that you're seeing here, the operating system's BitLocker protected. And I've had a real challenge for quite a while of how to actually demonstrate whether a drive is encrypted or not. And a dev and I came up with this tool. And basically what this tool does is at a very low level, it allows you to look at the contents of the drive from an entropy perspective. So I'm just going to let this run through for a second until it hits some nice interesting data about there. So what this drive is actually doing is it's scanning on a block by block basis the contents of the hard drive. Each of those lines you can kind of see at the bottom represents 10 megabytes. And what it's actually representing there is from the bottom, the other way around, from the top ASCII 0 to the bottom ASCII 255, and it's showing you the deviation of how often each character appears. And therefore you can see a pattern here. There's peaks and valleys and troughs. In the top right-hand corner, you can actually see a bar chart representation of those characters, again 0 to 255, and the yellow bit is the standard printable character set. So what this quite cool forensic tool is actually doing is analyzing the contents of the disk and effectively showing you the entropy of it. Now, the stuff that I'm actually showing you here on the S drive is effectively the early boot code. That is this drive here. And it has got nothing of terribly great interest in it. Most of the files are actually hidden. I'll come back to that in a moment, but from a BitLocker perspective, it's not actually a threat that those files are in clear text. because they actually get measured by something called the static root of trust measurement, and I'll quickly go over that in a second. But so I've shown you an unencrypted drive, so let me show you what an encrypted drive looks like. Oh, no, wrong one. And it's pretty flat and boring. Now, there's a reason it's pretty flat and boring. That's because every character within a tiny margin of error is appearing exactly the self-same number of times in 10 megabyte chunks. If you look at the bar chart on the right-hand side, it's showing you the distribution of those characters. And basically what it's saying is every character in the character range from 0 to 255 is appearing exactly the self-same number of times, which over the 233 meg we just read is a pretty damn good indication this hard drive is encrypted. Because that's the only way you have that level of randomness. There is no discernible pattern, if you will. So if you believe me in this tool, we will also use this tool now to look at a couple of the other drives. So let's look at the E:, which is the document drive, and well, it's pretty much the same story. And let's look at this no label, no file system. This tool can't actually understand anything about this drive. That's the one that's represented by F: here. It doesn't know anything about it, but I can tell it's still encrypted. I don't know what's on it, and I can't actually mount it, but I can see that it's an encrypted drive. Now, I've logged in here as a standard user, and obviously I can use my machine as one would expect. Under normal circumstances, I would have set up group policies so that S: was hidden, but for this demonstration, I didn't want to do that. But under normal circumstances, I'd have my operating system drive and my data drive. So what's this F:? Well, as I mentioned, I as a user can't access it. But either through a script or in fact through the UI, and I mentioned I wasn't admin, so I, being a good corporate citizen. So here we can see the tool, and as you can actually see, you can actually see that I've got the drives here shown as C: and E:, and they're both unlocked. Now we've got this F:, and it isn't unlocked. It did not have the auto-unlock parameter set when I initialized this, and you could do it through script or the UI, which means the key to unlock that drive is physically not on this box. Okay, so that effectively is a cryptographically secure vault, unless I can supply that key. Now, I can supply the key from removable media, i.e. one of these if I was an admin. Let's say I've just walked to this machine, or if I'm remoting in, I could supply it manually by putting an input or sending a file. So I'm going to manually enter the world's weakest password. It's all zeros, frankly, because I can remember it. I'm going to click on next, and what's going to happen now is this piece of code is IOXILing down to the driver, which will allow the driver to grab the key that's been presented to it, allows it to mount it. The volume manager's been passed the key. A component called fvvol.sys, which is actually the bit that does the encryption on the fly, has got access to the key. The volume manager can now map the drive, which means the file system, which lives above the volume manager, obviously, can now understand this is a hard drive, and lo and behold, I now have access to this particular drive, either here or in the other tool that I had set open. You can see it says mounted as F:, it knows how big it is. This is actually the contents of it, and in this demonstration, I set it up full of admin tools. Now, what I've just described here is quite an interesting set of scenarios. So you can set up BitLocker in SP1, so you could roll it out so you've got multi-volume support, but one or more of those volumes could be encrypted and on the drive and only be unlocked by people with the appropriate access permissions. You could put perhaps images of software in there. You could put support tools. I mean, whatever. There's all sorts of interesting options. But what this quick demonstration helps show you is that either interactively or through a WMI script, because everything in BitLocker is pretty much tied up to WMI, you can actually mount a volume either locally or remotely. And that's, I hope you think, kind of cool. So let's go back to the slightly less interesting deck. So, okay, so that's a real quick overview in simple terms and a demonstration of the types of multi-volume support we've got. I'm now going to start digging into some of the components, and I'm going to bring in some of the new technologies as well. I wanted to quickly discuss the Trusted Platform module, but before I do that, can I see a raise of hands of all those who are familiar with what a TPM is? Oh, bloody hell, that's everybody. All right, there were a few not, so I'll run through this real quick. Trusted Platform module is effectively a cryptographic code processor. It was created to a specification itself created by a group of luminaries called the Trusted Computing Group. The TCG is a group of companies, of which Microsoft is one, that are working towards the concept of trustworthy computing, like, as is Microsoft, of course. And the bottom line is the Trusted Platform module can perform a number of functions, some of which BitLocker Drive Encryption leverages in its day-to-day operations. But it can do things like signatures and hashing, and it's really good at random number generation. And it has certain physical attributes that help protect both the chip and the secrets that it contains. So I mentioned earlier this thing called the static root of trust measurement. I'm going to go over this fairly quickly. The bottom line is the static root of trust measurement is a way to help solve the answer of where do you put the key. Traditional solutions, I'll use that word, used to unlock a volume because they relied on the user supplying key entropy. In other words, a user had to type something in or present something and plug a device in. They had to do something for the OS to be able to mount. That has a couple of problems. People have a habit of forgetting passwords and losing dongles, and generally, that has a higher total cost of ownership. So what BitLocker does is it leverages the TPM chip and this thing called the static root of trust measurement. The static root of trust measurement effectively is a snapshot of all the code that boots up until a certain point. It is effectively, if you will, a photograph of the integrity of the early boot process. Basically what happens is there's a section of BIOS that has some TPM init code in it. That's the stuff on the top left-hand side. Its job is to initialize the TPM, and what it then does is it places a measurement, a hash, if you will, into a specific register. Well, what that piece of code then does is it goes to execute the BIOS, but prior to executing the BIOS, another measurement ends up in the TPM. The BIOS does its power on self-test and the other jobs it needs to do. It sends a measurement of the master boot record into the TPM, and then the master boot record is loaded and executed. Effectively, what you do here is you build up a profile of measurements in special registered in this chip. So little pigeonholes, registers, if you will, that hold a cryptographic value that represent a signature for each of these pieces of code. Well, this sort of knee bone connects to the thigh bone logic, continues all the way down to the OS loader, when the OS loader is going to execute. When the OS loader is going to execute, it needs to be able to mount the volume that the operating system is going to boot onto. What it will then do is the OS loader will pass an encrypted key blob, this key blob being a key that is actually required to mount and access the drive. It'll pass this encrypted key blob to the TPM, and it will say to the TPM, unseal this for me. An unseal is a special word for effectively decrypt this blob and give me back the key I need. The TPM can and will only do that if all of the measurements are correct, i.e. nothing has changed in any of these measurements. What that means is if you try and boot a CD or a DVD, you won't be able to mount the hard drive because you can't get hold of the key. If you modify any of this code to try and circumvent the boot process, you will change one of the measurements, which means you will not get the key. The only way you'll get the key is if you boot this process normally, and the TPM can return the key to the OS loader, and then the OS loader will continue. Now, in BitLocker, we've got a number of options as to exactly what can be measured. In fact, as you can see there are 16 registers. And we provide effectively a set of tick boxes and settings that exist in group policy that allow you to include or exclude different components in your own personal assessment of what you want the static root of trust measurement to be. Now, there are certain things that you're always going to want included. You've got firmware, you can have option ROMs in there, you master boot record clearly in the early boot code, and you can select using literal tick box exactly what you would like to have measured. And your measurement profile is effectively what you will create and measure every time that machine boots. As you can see there, there's a set of default options, but you can add others. you'll notice in there option ROMs are not included by default. There's some interesting reasons for that. You probably do want to measure BIOS, but the thing with option ROMs is there are some situations where option ROM loadout can change. The most notable one is when you've got like a little laptop like this one here that doesn't actually have a DVD drive in it. Now, they supplied me with a really nice, cool and swish kind of docking station that's got a DVD drive in it and a network connection and all sorts of other fun stuff. But the thing is, when I connect this machine to a docking station, different option ROMs load. When it's not connected to the docking station, a different set of option ROMs will load. So what that means is if you include all those option ROMs in your measurement profile, your unlock state, or go, no go for unlock if you will vary depending on whether that machine is docked or not docked. Now, recent machines haven't been that way. In fact, frankly, it's somewhat older machines that tend to suffer most from this interesting problem. But nevertheless, it's something worth bearing in mind when you look at doing your own BitLocker rollout as to exactly what options you would like to include in your measurements. So we're talking about keys. Let's talk real quickly about key abstraction. So we've got a concept of the volume master key. That's the large band that runs from top to bottom. It is an intentional layer of abstraction from the full volume encryption key. So the full volume encryption key is the key that actually does the encryption of the sectors and the blocks on the disk. And that's the thing that will be stored in FEVol.sys that actually decrypts and then re-encrypts, depending on the way up or the way down, the data that's going to be read to or written from the disk. That layer of abstraction there exists for a reason, because it allows us to rekey upstream if something downstream gets broken without having to decrypt and then re-encrypt the whole drive, which of course would be something of a pain. We've got a couple of options here. I'm going to go through them real quickly. TPM only, so that effectively means that the TPM is the one mechanism that's going to be used for a key release decision. You have TPM and PIN, as the name would suggest. That is the trusted platform module and a pre-boot pin. You have TPM and startup key. That is, the user must provide something on a USB device, as well as the TPM, its measurements passing correctly. In other words, the environment is unmolested. You have clear key. That's a system that's used to allow you, an administrator, to easily move a drive from one machine to another. It allows you to temporarily turn off BitLocker, if you will. So it deactivates BitLocker, so a clear key is written to a particular place on the disk. Effectively decouples the full volume encryption key from any other mechanism other than this clear key. There's a number of reasons why that might be useful, not the least of which is moving a hard drive or maybe an offline update, maybe an unattended scenario. The bottom line is you can then rekey it, and when you do the rekey, that position will be overwritten using a military of defense strength overwrite algorithm. Startup or recovery key, as the name suggests, that's a physical key that would previously be escrowed that allows you to get access back to the disk. And then a recovery password. The recovery password is a textual representation of that key, because we've tended to have found that when people are told very large hexadecimal keys over the phone, they very rarely type the damn things in properly, because most people are lousy at hex, but they get numbers and letters real easy. Numbers especially. So that's a textual representation of the key, if you will. There is another key example that's not up there that we've actually added in Vista SP1. We had some organizations ask us to add tri-factor pre-boot authentication. It's not in this diagram because it's literally pretty darn new. But effectively in SP1, you will have TPM, USB device, and PIN. So basically, it's two somethings you have and something you know is required to unlock the drive. And when you consider that there are USB manufacturers out there now that have also got biometrics built in there, you buy the right USB device, you can have four-factor, go mad as you want, really. But generally, I would recommend that you consider which option quite carefully. I would say TPM on its own has the lowest total cost of ownership because it's a seamless experience. So you're balancing absolute security against total cost of ownership and ease of use. TPM only, you're relying on the TPM manufacturer's quality of their TPM chip. It gives a good security bar. It's the lowest cost of ownership, assuming you're ordering machines with 1.2 TPMs, of course. It's a good standard for probably most people in an organization. TPM and startup key, interestingly enough, has the highest cryptographic strength because we can easily put 256 bits of AES entropy on this. That's easy. You'd never expect anyone to enter 256 bits of AES entropy. Whilst this is theoretically stronger than TPM and PIN, in the real world, TPM and PIN is stronger. Why? Because this will be in the same bag as the laptop every single time. Right? Or it'll be left on the desk with the laptop every single time. Unless your person has a habit of putting this thing on their keyring, the chances are that this in the real world probably has a slightly lower security value, unless you take advantage of some of the other USB devices out there that have identification mechanisms built into them, some of which I've just mentioned. But for your standard USB device, assume the user's going to leave it in the same bag. That's what I do. The PIN itself can be between 4 and 20 characters. I always recommend 4 to 6, maybe 8. That doesn't sound an awful lot. It's actually stronger than you'd think because the entropy of the PIN gets fed through into the TPM every time the TPM is asked to unseal a secret, which means if someone's hammering on the door trying to guess it, the TPM's built-in anti-hammering technology takes over, which means very quickly you get to the heat death of the universe before they've actually guessed the PIN. Right, so that's a pretty good way to actually realize that the strength of a PIN is a lot more than the 4 characters may actually appear to be. So let's talk about what the encryption does, because I've talked about the key algorithm somewhat, but let's see how it works. So hello world, plain text, and the full volume encryption key. Now, we have an optional algorithm here called Elephant, and what Elephant effectively does is address some admittedly edge case threats, but there are some edge case threats out there, and basically some inherent problems with AES 128 and 256 when used in CBC mode, which is the mode that we would use it on encrypting a hard drive, especially when you consider that you can't change the size of a sector, right? So our encrypted text, our ciphertext, always has to be the same size as the plain text, fairly obviously, otherwise we'd break the drive system. So there are some potential threats for boundary attacks. I actually haven't got the threat in here, which is perhaps a miss. I'll describe it real quickly. A boundary attack is where I change the context of the ciphertext. So I flip a bit in the ciphertext. I have no predictable idea what that will result in. But if the boundary of what my change is, let's just say 512 bytes, i.e. 1 sector, I might have a better chance of making a predictable change to the operating system's operation or an application's operation. Let's pretend for a minute somehow I figure out, I don't know how you do it, where the registry lives on the hard drive. And let's say, for example, in the registry, there's a setting Bob equals 1. Right? If that 1 happens to fall on this boundary that's 512 bytes, I can flip a bit. Now, I don't know what that contents is going to be. It's going to be squiggle marks and smiley faces. But if the application is checking for Bob not equal to 1, I've made a change. Because the application's checking for a constant, and yet I've flipped the context of the plain text without knowing what it's going to be, but nevertheless affected the app. But what Elephant does is it actually it dominoes, if you will, the net result of changing 1 bit in 1 sector by affecting a far larger area, if you will. In fact, it will change it down to an entire cluster, a block, if you will. So the statistical odds of being able to pull off such an attack they were slim to start with, they're significantly slimmer now. Because if I flip 1 bit, I change a much bigger group, which means the chances of me pulling off this edge case attack are significantly less. So that's why this exists, and that's why one of the reasons why we also derive sector keys, because the same algorithm uses the sector as part of its seed. The other reason we do that is to address some form of attacks where you might write an application that writes a gig of the letter A, a gig of the letter B, a gig of the letter C, a gig of the letter D, etc. And then you use cryptographic analysis methods to look to see if you can see any repeats or any patterns, and theoretically, although AES hasn't been broken, we want to make it as strong as possible. So that's why this algorithm exists. There's a really cool white paper on it. It's called the elephant algorithm, following the concept of naming algorithms after creatures. And it was actually written by Niels Ferguson, who's a pretty well-known name. He worked on this project with me and others. He's worked with Bruce and a few others. He's pretty well published. His algorithm's going through some pretty intense review, as you can imagine, before we published it. Trust me, it's really cool. This is what this diagram is going to show. So we derive the sector key. That can get fed into this diffuser algorithm. The diffuser algorithm then feeds into an AES algorithm, along with the FVEC, the full volume encryption key, creating quite a high entropy key that ends up with the encrypted sector. And yes, it's ROT13, but that's because if I did it in AES, no one would know. So that's basically how the encryption cycle works on the disk and where the diffuser fits into that scheme. It's an option. It's on by default. You can turn it off if you so desire. Your options for encryption are AES 128, AES 256, both with and without this algorithm. So let's have a look at this key protectors. A BitLocker follows an object-oriented methodology. The concept here of a protector, it's a piece of code that has known inputs and known outputs. It's actually an extensible model. It's been pretty well documented. For example, we added the TPM plus PIN plus USB protector. And theoretically, anybody else could add protectors as long as they follow the prescribed model. But the bottom line is the data is fully encrypted, and as you can see here, the key goes through various stages, and this basically just shows you the different keys building on top that allow you to get access to the volume. You'll notice that there's a segment there that's in blue. That's effectively the bit I showed you on this other machine earlier. A BitLocker requires a separate small mini volume in which the actual pre-boot code exists. It's just a hangover of PCAT infrastructure that BIOS is always expecting to find the master boot record in a specific place. And fine, you could then load your own master boot record and go and do weird and wacky things, but we decided we didn't want to do weird and wacky things because whenever anyone starts waving their hands, security people tend to get quite concerned for good reason. The bottom line is we decided rather than try and hide code and hidden sectors or mark sectors as bad or any of that other rubbish that you can do, we basically decided that there's a very well-known model for containing data, and it's called a partition. You know, it's been around for 20 years. So the bottom line is the pre-boot code must exist in the partition. It's a limited piece of code, and as I showed earlier in the static root of trust measurement model, it's not a threat because it's measured. If anyone changes it, it'll break. Now we recognize, of course, multi-volume partition rollouts can be a challenge to some organizations. First of all, let me assure you that it's something that's been around for a very, very long time. If any of you guys have bought a Dell or an HP or a Lenovo, an IBM, or in fact almost any machine, especially if it was a home build machine, the chances are you've actually got a hidden partition on there. You just may not know it. Many OEMs ship multi-partition machines now, and in one partition they hide stuff, whether it's recovery tools or WinRE, the recovery environment, or whatever. But we recognize you may have an upgrade, or you may have an environment, or you may have homegrown tools that don't support multi-partition, multi-volume rollouts. Well, we've addressed that in a number of ways. System Center Configuration Manager, which just went live last week, I believe. SCCM, by the way, is just the new branding for SMS, thank you. And yeah, basically it's new and improved SMS, and it supports BitLocker. But we recognize you may not use System Center Configuration Manager, although I'm sure my boss would like that you did. But if you don't, we've supplied tools that allow you to convert a typical single volume environment into a BitLocker friendly one. So what you can see on this machine is, you know, I've got some unallocated space. That's just because of the way I set this machine up. And you've got, you know, your standard single volume type environment. And if I go over here, I have something called the BitLocker Drive Preparation Tool. And it requires admin privileges, naturally. And it has your pretty standard disclaimer that says you should back up your data because we're going to be moving volumes around and making changes. This is kind of an important task. You can run this tool in a number of ways, but the bottom line is what this tool is going to do is it's going to shrink the C colon volume here. It is going to create a new volume, which is typically S colon, but you can give it parameters, right? And it's then going to move the appropriate operating system files into that S colon. It's then going to mark that as the boot, and it'll leave the rest of the operating system in what is currently C colon. And believe me, from a demo perspective, this really is flipping the cards of fate. So this is going to take a few minutes. So as you can see, whilst it's creating the S drive, it's wandering on a few percent. I'll move on, and then when it's finished, we'll come back to it, okay? But what this is doing right now is this is turning a very simple single petition into a BitLocker-friendly environment. Like I say, it'll do all the repetitioning for you, move all the drives, make all the BCD setting changes you need. Once this is finished, you'll be able to turn on BitLocker on this machine. That's pretty much it. So I'm going to leave that running, and I'll come back to it in about, by the look of it, a couple of minutes. So let's move on. So we're talking about partitions. Excuse me one second. Thank you. There are a couple of recommended ways you can roll out BitLocker. So WinRE, as I'm sure many of you know, is the Windows recovery environment. It's basically WinPE with some extra stuff on. Right? And the extra stuff has a number of tools that help you to do typical recovery tasks. And WinRE is BitLocker aware. That means it has BitLocker code built into it. BitLocker key recovery code is actually in WinRE. So if a user boots into WinRE on a BitLocker protected machine, they have to enter their credentials, very much like I showed you earlier, to mount that data volume drive before the tool will get access to the drive. So it's quite a cool concept to have a WinRE partition. You can have WinRE on a separate partition, the top one, or you can actually have WinRE as marked in the active partition, like the bottom one. So kind of your choice. The example I chose, you could imagine perhaps that the WinRE and perhaps some other tools were in partition 2 there. That's the partition that I had that was encrypted but not locked on the machine. Right, that was quick. I'm going to quickly switch over back to this machine. So as you can see now, this machine, it's created the partition, it's prepped the drive for BitLocker. It's going to tell me I'm going to need a reboot, of course, because I've fiddled with the drives an awful lot. As you can see, it's created the S colon, it's healthy, it's shrunk C colon slightly, it's marked it active, and when I go to restart this machine, and I'll have this happen in the background, I could just activate BitLocker either through the UI or through a script, very much like I've run this tool. So this is a really good answer for those people out there who've already got single partition machines, who get their machines single partition, who are doing upgrades from XP in place, or don't have tools like SCCM that allow you to do multi-partition rollouts very easily. Let me just reboot that whilst we're waiting. So where are keys kept? Well, the drive is split up into a number of interesting ways itself in a particular volume, and effectively there's metadata stored within the volume that creates, very much like good old FAT32 did, a linked list of contents pointed to next set of contents pointed to next set of contents. This effectively intentionally scatters copies of metadata, and as you can see on each end of the disk, the actual boot sector, in logically top, middle, and bottom parts of the disk. The reason we do this is in case of a disk crash. If you have a head crash, it's possible that you may put your machine into a state and position where you'll need to be able to read this metadata to get the information off it, especially if your vice president of whatever forgot to back up that very important document they were working on just before they dropped their laptop, right? So recognizing that this is very important, we've actually got a well-known pointer infrastructure that allows you to quite easily find where BitLocker keys exist. So basically, we provide tools that do this kind of automated searching, starting from the top. If the forensic tool finds a corrupted version, it will move to the next version, and so on and so forth. We provide a number of forensic tools that allow you to actually regain contents and access to the disk. There's a recovery agent actually built into the boot code itself. That's the one you'd use for a normal scenario where someone's perhaps lost their USB stick or forgotten their PIN or whatever else they may have done, right? We provide tools that allow you to mount a BitLocker drive, so we've got tools in WinRE and separate tools, so if someone brings you back a laptop and they spill coffee all over it, if the hard drive spins, you just pull it out, put it in a chassis, you can mount it. And if the hard drive suffered a crash, you can use these types of tools that will allow you, even if the file system itself has been corrupted, and even if some of the metadata has been corrupted, will give you a very good chance to be able to find sufficient data to read the contents of the disk. Even if all of that is broken, you do have the option of escrowing the FVEC itself, which means you have the option of escrowing the full volume encryption key, the key literally used to encrypt the blocks on the disk. If you have done that, you supply the key to an application we've provided, and that will effectively do a bit copy of the disk for all sectors it can read and do the decryption using the FVEC you've supplied it, which will allow a full data center to be able to do a full recovery if you've chosen that option. So we've pretty much got recovery covered, I feel. I'll point out that the last option's highly unlikely, because if you've had a head crash that's taken all three of these out, whoever it is has pretty much toasted their drive, right? Because you've had the head skip across pretty much the whole drive. You're not likely to get much fun back. These are a number of the options we've got. I mentioned that you've got the various PCRs that you can set. I talked about that earlier. And any number of control options that allow you to set what a key mechanism you want to use. But I want to point out that we recognize that threat models change. Threat models change regularly, and we actually, thanks to our key abstraction, we allow you to rekey BitLocker pretty easily. So let's imagine a pretend scenario. I'm just going to quickly use this wonderful tool called Manage BDE. It's included in the box. And what this tool has shown me is, here are the three volumes I've got. The first volume, it's encrypted. You can see it's got a numerical password. That's the numerical recovery key. You can see you've got the external key, that's the AES key, so I've got both a textual representation and an AES key. Both of those are escrowed back at Microsoft's Active Directory service interface, where those keys can be escrowed. And it is protected by the TPM. You can also see that I've got the other devices protected, and you can actually now see that F colon is unlocked. Let's say for a minute, let's say hypothetically for a second, I don't know, you've got Model A, and Model A machine has got a TPM in it, and you hear of a BIOS bug that causes some form of a problem with the TPM. I highlight this is entirely hypothetical. I know of no such problem. But I'm in the security business, so we think about disaster scenarios fairly regularly. And one of the things we allow you to do is rekey on the fly. If you remember that abstraction key, that allows us to do that. So at the moment, this machine is set up for TPM only, and I can easily change it for TPM plus PIN, and I could do this using this tool. Oh. I forgot a dash. So I can use this tool interactively, which allows me to change the protection models. So what I've just done, and literally it's that quick, is I've rekeyed, thanks to the abstraction layer, the key required to actually get to the full volume encryption key. I've changed it from TPM only to TPM plus PIN, and as you saw there, well, the PIN's, again, a really awful security one. It's 4 zeros, but again, I can remember that. Now you could have done this through a script, you could do it through WMI, System Center lets you do it. I showed you this example here with a script has allowed me to very quickly and interactively change the protection model on the fly because threats change. And it's quite easy to change it back too, because what I can do it's gone, and then I'll just add back the standard one. I can't type on this tiny keyboard, apparently. That's it. So I deleted TPM plus pin, which means this machine no longer requires a pin, and I've just retied the key to the TPM. The bottom line is we've got a number of options that we allow you to leverage, and they're very flexible, and they can be very easily changed completely on the fly, even through scripting. Okay. So here's something new and interesting that we came across, and again, I think you guys are the first to see this, but what about weak passwords? So it's wonderful, isn't it? So you've got your BitLocker protected drive, you've got your C colon protected, you've got your D colon protected, you've got wonderful tools hidden off an E colon, but what about those users? You have thousands of users, those users who've created weak passwords. BitLocker is designed to address a particular threat model. The threat model is protecting the data when the data is at rest, the offline attack vector. There are other technologies that are designed to authenticate users. They're called credential providers in Windows Vista, and it was Gina in XP. Right? And bottom line is there are a number of tools that we've provided in Windows Vista that allow you to, for example, use a smart card as a user login model. But let's face facts, most users are still using passwords. And certainly customers I've spoken to have said, well, it's wonderful we're using BitLocker, but we're especially concerned about weak passwords, especially for targeted attacks. If you think about a bank or a biotech, a petrochem, anyone that's got a VP of something or a SVP of something else, you've probably got a risk of a targeted attack. That means a bad guy is going to steal that person's laptop intentionally as that target is known to probably have high-value information on it. If they've done their homework, it's a sad but inevitable fact that most people will pick a password that's easy for them to remember because we're people, right? So just a relatively small amount of investigation on the individual you're targeting can significantly reduce the number of guesses you need to try and figure out what their password is. And once you've guessed it, you're in. You would be amazed, we've done studies, you would be amazed how even though you can set a password policy that says uppercase, lowercase, and numbers, in exclamation marks and whatever, how often people would use ats instead of a's, their birthday and their wife's name and think it's really clever, right? Well, it isn't, and it will be discovered relatively quickly, and frankly, it's still a weak password. Now, you would think, well, that's outside the threat model of BitLocker, and you would be absolutely correct. However, custom credential providers, let's think about that for a second. The whole concept of a credential provider was to replace Gina. I don't know if anyone here has ever devved with Gina. I did moons and moons ago. And frankly, and no offense, but Gina was a tentacular monstrosity. Working in Gina was an absolute nightmare. You had bits of code in ring 3, stuff winding down into 0, writing a custom credential provider was an enormous difficult task. It was fraught with danger because you ended up touching so much. We changed that in Windows Vista to a more object-oriented approach so that you could write these things called credential providers. As the name suggests, a credential provider is a component of code that you can plug in that does a task. Well, I just showed you how you can manage and delete keys. So logically, if we think about this for a moment, an idea quite literally occurred to me whilst I was talking to a couple of customers. We could blend these two technologies together and actually help create some protection against weak passwords. The bottom line is, what we want to do is we want to help against dictionary attacks, we want to keep the solution simple, and we want to leverage WMI and API calls that already exist. And the solution to that is create a custom credential provider that leverages a BitLocker key deletion strategy. So what we did is we've created a custom credential provider, and this one happens to be a username password one, where if after a parameter number of failed guesses, it deletes all the keys on the drive except the recovery key, and then reboots the machine. What you have now done is if someone guesses the password wrong n number of times, it turns the disk into a cryptographic brick. And the only way you can get access to that disk again is if you happen to have the recovery key, which in normal situations would have been escrowed to Active Directory, because BitLocker in most organizations will have the key escrowed in AD. We intentionally limited it to that level of key destruction. We could have deleted all keys, but frankly, the scenario came into my head was, you know, if a father took their family to Disney World to do a presentation, and little Johnny gets hold of the laptop key and wants to see what Donald is doing today, and just keeps on hitting the keys a few times, and suddenly Daddy's no longer at Disney World because he's got to go back to clear out his desk, right? That would be bad, right? Clearly. So what we did was we created a model that it deletes all the keys except the recovery key, and then whilst little Johnny's standing in the corner, he can phone up the help desk and he can type in the recovery key and everything comes up again. So let's actually talk about it. I mean, it's a really cool, if you think about it, it's a really cool way of blending important BitLocker technologies with the rest of the kinds of technology that we've built in Windows Vista. But let's talk about it in a little more detail. So basically, as you know, you've got n number of sessions, you've got the win logon component, and I'm not going to, this isn't a credential provider talk, but in simple terms, the whole login structure has been broken out into multiple components. You've got a UI, the concept of the default credential provider. Actually, there's more than one. You've got a username password one, and you've got a smart card one. And then we've got this sample that we've created, and I'm going to demonstrate in a moment. The bottom line is the sample credential provider leverages the BitLocker assembly and the WMI provider for BitLocker, which, if memory serves, is Win32 encryptable volume. Very well documented, gives you access to all the key delete, key add, and all the other types of functions you would need. And it leverages Win32 APIs just for some general tasks. Oops. Okay. I know why that happened. Thank you. Right, so here's a login scenario. Kind of starting up in the top right-hand side. You're going to log in. It's going to pass your login to the default credential provider through LSAS. It's going to say, have you logged in correctly? You'll jump down to yes. You put in the correct username and password. You may log in. If you have failed, there's a check counter. The check counter goes to the registry to see exactly how many times you're allowed to get it wrong before your machine goes bye-bye, frankly. It will come back and it will say, have you reached the max? No? Well, then it will go back to the user login provider. Yes? Then it will go into force recovery, which basically talks to the BitLocker components and effectively makes calls to delete keys, kind of how I showed you in Manage BDE. Then it forces a shutdown. And when you reboot, you'll be in a BitLocker recovery screen. To answer some questions that normally come up when we were doing this discussion back at home, what happens if someone can get into the registry to change the number of force recovery to an infinite number? Well, let us also remember that when this piece of code isn't running, the whole drive is encrypted, so they have to break AES to be able to change the force recovery number. If they've somehow broken AES, well, they're world famous for one thing. And secondarily, why bother with anything else? Because you've broken the key, you have access to the disk. Right? So it's actually quite a secure model because the infrastructure of this model, let us not forget, when the disk is at rest, is in and of itself protected by BitLocker drive encryption. So here's the concept. You've got perhaps TPM plus PIN or whatever, and you've got the recovery password that's been previously escrowed to Active Directory. As you all probably very well know, BitLocker supports a number of ways of escrowing your key when you activate it. Into Active Directory is probably the one most popular. And effectively all we do is jump on that. By jumping on that, I can't recreate the full volume encryption key. I just can't get there. The thing I need is the recovery key, and that's not physically on the disk. That's generated once during the instantiation of the feature and then escrowed. It exists in memory one time, never goes to the disk. So this is going to be an interesting demo. Let's see if we can get this one to work, shall we? The new credential provider can be signed, and under 64-bit, it would actually have to be. So the question was, does the custom credential provider have to be signed? So the one we're giving as an example it's not actually on the web yet, but when it finally gets polished a little bit, because it's kind of rough at the moment, I did say you were the first to see it, right? But once it's actually polished up, we're probably going to just put it on the web. Obviously, people who write credential providers should sign their code, right? And whoever the third parties are will sign them. This isn't a product we're going to be providing, just to be clear. This is an example that we'll end up putting on the web for you guys to read, enjoy, propagate, leverage, put into your own environment. Really is a way to show you how the technologies blend. It's also a way so our partners can look at how they can add value. And I strongly recommend, in answer to your question, you tell your partners, sign your code. All right? Sign your code. Get used to it, because 64-bit, it'll be a requirement. Well, it is a requirement anyway. It's just good practice for 32-bit. Okay? Right. So here we are. Can you see? Oh, we can see the screen. So this has a number of video resets, which from these box perspectives is always fraught with danger. Now I actually have both credential providers on here. The one that effectively is the ticking bomb version, and the one that isn't. So as you can see here, I've got login attempts, and this is just for demonstration purposes because we knocked it together so you could see what's happening. And once I get it wrong a few times, it will fail horribly. And we're nearly there. Once more, say bye-bye. It says actually welcome, and now it'll say bye-bye. Right. So basically what's happened now is it locks the machine. It actually it unlocked the machine for a microsecond to run the delete key, which is why you saw welcome pop up. I haven't quite debugged that bit yet, but we'll get there. It deletes the key, actually multiple keys, leaves the recovery key, and as you can see, forces a shutdown. You are still you're not in a user session yet. You've not actually logged on as a user clearly, so there's not, the risk of data exposure is remote in extreme. So this machine's going to shut down. I'm just going to let it shut all the way down for a second, and then I'm going to power it up. And this demo, the last time I did it, as we were going through the power up, it took a moment for this video box to actually catch up. So I'll fill in the blanks with a little story now. Here we go. Right, so the bottom line is this machine has now been put into a recovery mode. This is what a recovery mode looks like. Now, there are a number of reasons why you might see this mode. If you've forgotten the key, if you've pulled the hard drive out of one machine and put it into another machine, the TPMs don't match anymore. There are a number of reasons why you could get here, including if you're using this custom credential provider and you've put the password in wrong a number of times. So in this scenario, I put little Johnny in the corner and leave him there for a little while. I get on the help desk and I can then go into recovery mode. I can go into recovery mode and I have a couple of options. I could have just plugged in a USB stick, hit the key, and it would have automatically recovered. But I strongly recommend you don't give your recovery key to your users on a USB stick because it'll be back in with the laptop again, right? The bottom line is it's designed so the recovery key is separate from the physical device. So in this scenario, what I would do is I'd get on the phone, I'd phone help desk. Hopefully they would do a meaningful challenge response to prove that I am who I say I am, rather than just trust me. They can actually identify what volume I'm recovering, because you can see both the drive label and a password ID. Now, I mentioned we support multiple volumes, and that's important because you can have two BitLocker protected Vista partitions on this machine and two data volumes that are also protected. Each one of them will have a unique ID and probably drive label, but definitely password ID to identify which drive is the one I'm trying to recover. So on the help desk, I say, hi, my name's Russ Humphries. Yeah, the kid put the password in wrong. Drive ID is blah. And then they read out the recovery key to me. And because I have a lousy memory, just by sheer coincidence, the recovery key is really easy to remember. Right, so now what's going to happen is the machine is hopefully going to boot. Now, the last time I did this run through again, it took this machine a little, if I actually didn't see all the pre-boot screens, it actually only saw when Windows come live. But I can actually see Windows starting to come live now, the little bouncy bar at the bottom. For some reason, it didn't capture it until we actually get to the little circle, but it'll get there in a moment. But the bottom line, what I've just done is unlock this machine for one instance. If I was to turn off this machine and then restart it, there we go, good. If I was to turn off this machine and restart it, I'd have to enter the recovery key again. In other words, the recovery key is not rebound the volume key to the TPM. I would have to run a script or a command to be able to do that. So again, as I showed you earlier, that's pretty easy to do. I could do it. Actually, I'm a switch user. No, I'll do it for you. And I'm now authenticated. Prior to this, when you saw the black and white screen, a cryptographic brick. If someone had stolen this and was trying to guess my password, they got there 5 times, which is like, if they can guess it in less than 5, they had it written on a post-it note on the cover, probably. But if you get to like 5 attempts, the disk was a cryptographic brick. Now, in the other scenario I described, I've just typed in a key, I have full access to the machine. I could now either run a script that would relink the keys up for me, an administrator could do it for me, or if I'm feeling like being a power user, I can quite easily do it myself. I have to run as admin, because manage BDE is an administrative tool. And because I'm a good corporate citizen, I'm running the least privileged user, of course. I do manage BDE status. It'll show me the status of the hard drives. You can see that, unlike last time, you can see that manage BDE doesn't actually know the size of that locked data volume I mentioned earlier, because I haven't actually provided the key to unlock it. I've rebooted, it's locked again. Doesn't know how big it is, does know it's protected. It says it's locked and auto unlock is disabled, so that drive is relocked again. And if we go up to C:, it's protected, it's unlocked, but as you can see, the only key protectors that exist are the external key, which is the AES key, and the numerical password, which is the one I just entered. So what I'll do now is I'll rekey it so. And now you can see it's actually relinked with the TPM. So if I was to reboot this machine again, I don't need any other passwords. It'll just automatically go through the login sequence and I'm in. Well, that's just a couple of examples, and clearly, I'm showing this interactively because if I was running secret scripts in the background, you probably wouldn't believe me, frankly. And besides which, it's more fun to actually see the command lines and stuff actually happening. I'm going to talk about guidance real quickly. I'm going to run over this real fast because I'm running out of time, but I've covered just a small fraction of the types of features that are available in BitLocker Drive encryption. There are a number of other security and data protection features, of which I will point out that least privilege, by the way, and the concept of least privilege is in and of itself a data protection feature. Believe me, user account control and least privilege is an important part of your data protection strategy, because if your people are running as admin, you don't really have a data protection strategy, because they can do whatever they want, install whatever they want, and therefore things can go wrong. The old security adage that someone would click through and answer, "Are you sure?" to see dancing pigs, it's still very true today as it was 10 years ago. The bottom line is there's a lot of tools that integrate together to provide defense in depth. User account control, the concept of least privilege, BitLocker Drive encryption, a slew of them. Device protection that allows you to control what devices can actually be plugged into your machine. That's an important part of a data protection strategy. Over 500 new group policy settings and an infinitely more controllable way of auditing at a more granular level, with the audits being created in XML, are all part of the new Vista protection strategy. I couldn't talk about them today because I would eventually run out of voice, but that's a really good book and a way to go find the kinds of information you need and are interested in to solve your data protection challenges. Some of the resources are up there. I'd like to make one final pitch. I've got a couple of other sessions that I'm running, and at the end of this week, I'm going to be giving away 4 copies of Windows Vista Ultimate. And Windows Vista Ultimate, as you probably know, has everything in it, including multi-language packs. So it is nationality independent, or at least as much as Windows is. It has BitLocker on it, of course, and most of the tools. I'm going to give away 4 copies, which you have to put your business card in there. I highlight that this isn't a marketing pitch, it's purely, I get the card, 4 people's cards will be picked out, they win, and you won't be getting lots of emails from the Microsoft marketing department. That's not how it works, okay? It's just to basically try and make you come to some of my other sessions. But the bottom line is I'll be giving away 4 of these. What I will also be doing is to the 4 names I pick out, not only will they get a nice shiny copy of Windows Vista Ultimate, but I will personally make sure that they are on the Windows Vista SP1 tap list, which means you and or your company get a copy of Windows Vista SP1 just as quickly as we're ready to release it out through the next tap cycle. So I'm pretty much done with the technical overview and the last little bit of pitch. Got a few minutes left. Why don't I open the floor to some questions? Now, could I ask you perhaps, there's 2 little QA points. Maybe you could perhaps wander to that question point, or because I probably won't hear you from back there.
You said on the TPM, you said SHA-1.
TPMs use SHA, yes. SHA-1, SHA-256 if memory serves, and I think they're updating that with TPM 1.3 spec as well.
Okay, but the 1.2 is on SHA-1, you said, or at least from your slide it seemed.
Pardon?
It looked from your slide it was only SHA-1 on the TPM 1.2.
Correct. Any other questions? Yes, sir.
Yes. If I use BitLocker with a PIN and then log into Windows with a smart card, do I have to enter a PIN twice, or could I pass the PIN to Windows?
That's a very good question. And the answer is you have to enter the PIN twice. Let me tell you why that's the case. There are as many smart card manufacturers, models, and methods out there as you could imagine, frankly. And for us to support any form of smart card infrastructure means we'd have to make some fairly fundamental changes to the way BIOS works. And that's really, really difficult. I know some specific boutique manufacturers and some OEMs are providing BIOS support for a given subset of their partner vendors, and that's great innovation. Microsoft, of course, has to be as much as it possibly can vendor independent. And as we were looking at the types of features and functionality for BitLocker, and I was the BitLocker PM, by the way, we looked at should we put smart card in, and then this wonderful thing called EFI sort of started to gain some significant momentum. And EFI is the sort of basically the BIOS replacement. It stands for Extensible Firmware Interface. It's already got some traction in the server world and is beginning to gain traction in the client world. The point of the Extensible Firmware Interface is frankly just that. It supports firmware in an extensible way. I can't make any promises as to the direction of, or development of a product, but assuredly that's much more easy and more palatable for us because we can be vendor agnostic than trying to support some vendor independent ways of getting smart card information from pre-boot environment into the boot environment. I know solutions do exist that claim to do that. You have some very significant and real-world problems with that. Simplistically, it comes down to you're having to manage 2 sets of credentials. If you're trying to use smart card to meter the lock or unlock of the operating system volume, right? That means you have to authenticate the user in the smart card before you unlock the OS. Once you've unlocked the OS, you have to pass that authentication data into the OS so the OS can log them on. And I know there's a lot of people out there who talk about single sign-on solutions, but there are certain synchronicity problems with having effectively 2 credential sets. You know, you've got auth here and somehow pass an auth here. And when the Windows infrastructure changes credentials or UI, UX, you know, for login name or whatever it may be, that's got to sync back out this way. Certainly when I spoke to customers, some of them claimed, and this is a couple of years ago now, but some of them claimed they had issues with that. All of those factors come together that I personally think that EFI and UEFI is an area where we will be looking more so to invest in that kind of technology than the BIOS world. Okay?
Okay, thanks.
You're more than welcome. 1 second.
Another question. Questions about the recovery key.
Yes.
The problem in a real world environment is if you gave the recovery key to a user, it can use it every time, and he will write it down because he can't remember those 40 keys digits. Why did we use a mechanism of a challenge response so that the recovery key is only valid for a certain amount of time, or just once, or whatever, not infinitely?
Understood. That's a very good question. You can rekey the recovery key, so you can run a script that allows you to rekey the recovery key. The default environment in which the recovery key is entered is very, very thin. All right. Again, for the same, basically a similar answer to the smart card. Could we have perhaps created a method where there was I don't know, an IP stack that allowed you to get out in BIOS to talk to a server agent? Could we create some other model that did more advanced challenge response? Yeah, we perhaps could have done. The way we actually allowed people to innovate in that space was provide support in WinRE. WinRE can effectively give you a pre-boot environment that Vista will default to if you fail to log in. Yeah. So let's say I showed you that partition image earlier. If you've forgotten your PIN, or you've dropped your machine or broken it or whatever, if you've installed WinRE, Vista can actually be set up to automatically boot into the recovery environment if it fails to boot into the Vista environment, including BitLocker authentication failures. When you're in RE, third parties or your own organizations can innovate to your heart's content and do whatever that WinRE environment would let you do. We've provided a very simple model in the boot components because there's not much there, so you had to keep it really easy. In fact, we actually had to even write in support for function keys. Effectively, we had to map function keys to numerics, and you'll notice it was numerics I entered. The reason we did that is, believe it or not, scan key numbers can vary in the BIOS world to the Windows world, but function keys always tend to remain the same because BIOS manufacturers use function keys to do stuff. Right? So we had to really write the first implementation to a lowest common denominator, but we created a system that allows third parties, ISVs, IHVs, large organizations, whatever, to innovate to their heart's content, and that basically was creating a WinRE environment that is rich and deep. I do know that certain BitLocker competitors, for good reason, I understand they're positioning their product, they make a big deal about the fact that they've got a number of recovery models. That's great, and that's fine. What they've effectively done is create their own WinRE environment. All right? They've effectively hand-wrapped their own kind of mini OS before the OS. Right? And in that environment, they put mass support, or maybe a smart card support, or IP stack support. But that's an enormous amount of threat model space. That's a lot of attack surface. And now you're trying to support two operating systems with completely different code bases. So my argument would be, consider if you want to create rich environments, add value into the WinRE space and run out your deployments with WinRE as the recovery model and Vista sitting next to it. And it's literally one switch in the BCD file that says, if Vista fails to boot, automatically start WinRE. And then, by default, it throws up a UX that says, give me a key. But you can change, it's just an application. You change that application to do whatever you want. And if you want to put your smart card stack in there, and you want to say, well, recovery comes via smart card or some challenge response system, go ahead, you're more than willing to do so. And frankly, it's time. You know, we developed all these models. We gave the industry plenty of space to be able to innovate, which I think is valuable and important. But ultimately, you know, deliverability is a feature as well, right? And BitLocker's pretty darn complicated, and as it was, we wanted to make sure that we delivered as much as we could. But I think that's probably the all-round answer.
Okay, thank you.
Yeah, you're more than welcome.
Hi, I just wanted to add to this question, but you answered the question already that I had, because my question was, the user is not in this place and he wants this encrypted partition to be decrypted. And like in other challenge responses, like you can say one-time logon, or that you can decrypt the partition or whatever, but you would advise that to add the Windows RE environment to the Windows Vista deployment when we would deploy it, so that my support colleagues can go to a computer, start the Windows RE environment, and have there the chance to decrypt the computer, the partition, whatever.
The WinRE environment is always, and the point of the Windows recovery environment is to give you richness. The RE environment gives you a mouse and full keyboard and a UI and a UX. So if that is a concern, and of course recovery, the total cost of ownership, disaster recovery is always a concern, I would recommend leveraging, putting WinRE on there, I really would. It doesn't take up that much space, it's like a gig, right? And these days, that's not much space. And you could put that environment there, leverage the existing tools that are BitLocker aware, or as I said, you could add value by adding your own. You don't have to do that. As I mentioned, there is that simple textual-only version built into the boot code, but personally, I would do WinRE as well, because for the sake of just a little bit of extra disk space, you've got a much more flexible, extensible, and user-friendly environment.
Yeah, and it sounds easier for my colleagues to use this instead of rescripting something. It's easier to do this. Yeah.
Clearly, that would be easier.
Okay, great, thank you.
You're welcome. I think I've got time for one more, so sir, I think you're the last.
Okay, you're advocating BitLocker, but how does it compare to other technologies to protect documents like EFS and RMS?
That's a superb question. So the question, just to reiterate, was I'm advocating BitLocker. I absolutely am. I also advocate RMS and EFS, by the way. They're different tools for different tasks. Okay. BitLocker is about protecting the lost laptop. It's about making as sure can be. You're protecting slack space, deleted files, temporary files, the hibernation file, and 101 other data points. It's not about protecting data with a user context. BitLocker doesn't know what a user is, and it shouldn't have to. It's about protecting the disk and what is on it. EFS has a user context. EFS is really about me protecting my files from someone else. So I would protect my content on a machine I might share, someone else may have access to. But EFS protected files are associated with my user login context. And we made significant enhancements to EFS in Vista, including smart card support, which means you can store your certificates and keys for EFS on your smart card. Okay? So that's significantly stronger. That means I'm protecting my files with my login authentication, my identity. RMS is about sharing information, frankly, with people you trust, which sounds a little bit of a dichotomy, but it isn't. RMS is about sharing information, but trying to protect that information, frankly, from the whoops factor. Whoops, I forwarded that document to the wrong person. Whoops, I didn't really mean to print that document because the printout's going to occur 5 buildings away, and I don't know who's going to have access to it before I get there. RMS is about the ability to share business-sensitive information with people whom you want to share it with, and not with people who you don't want to share it with. But it assumes a level of trust. If you don't trust an individual, don't send them an RMS-protected document, because they'll just take a photo of the screen. I mean, it really is that easy, right? Or they'll pick up the phone and read the contents. Or somehow they'll figure out a way. You send an RMS-protected document to protect a business relationship, a communication, whether it's one-way, two-way, whatever, and it's really for protecting against accidents rather than malcontents. And frankly, that's what most rights management software is about. I've run out of time. I'd like to thank you all very much for your attention. Please feel free to put your cards in the little bin down there. Please do fill in your evaluation so you get a chance to win this wonderful phone, and have a really good afternoon.